Hello all and welcome back. So in this video, let us now try to see different traversals which are present to us in our binary tree. So let's get started. Now talking about traversals, we have discussed the same in generic tree as well. That traversal is a way I can go or rather print my binary tree, I would say. So what is the order or how can I go to each and every node? Traverse on each and every node. Okay, great. So let us take a binary tree, say something as straightforward as this one to understand the concept majorly. Let's say this is a binary tree. Okay. And let me name the element as well. 1, 2, 3, and 4. So the very first one is something which we have seen and done already. It is pre-order. Okay. So in pre-order, we are already aware that root says or the parent says that hey, first print me, first traverse on me, and then basically go to my children, right? Something which we have also printed our binary tree on in the initial videos. So in this case, I will first come to parent and I will print its value. Then I will go to its child, print its value. Then I will go print its value. We will return. And finally, I will go here so that I can print the value. Parent is asking that, hey, first print me and then go to my child. That is what is known as pre-order traversal. Okay, great. So let me just write it a little bit more clearly. First parent and then child. So the order of my traversal, if we even try to print it, it's going to be something like 1, 2, 4, and 3. Okay. So parent asking first for itself and then for tree, then for its child. Let us see the visualization as well, everyone. So visualization will make it a lot more clear, right? So in this, we are going to visualize the pre-order. Okay, great. So let me click this button and see. First, 1 gets overall printed, then it's 2, then it's 4, then 3, then 8, then finally 6. So let me replay this so that you can see it. The speed is lowest only, should be fine. So pay attention everyone, what exactly happens. First 1, then 2, then 4, 3, 8, 6. Okay, so the order, if we just pay a little bit attention, the order is something like this. First 1 says that, hey, first print me or traverse on me. Then it's 2. See, 2. Then it's 4. 4. Okay. Then 3. After 3, it's children 8. And then finally 6. Okay. Great. So let us try to code this clear pretty quickly, everyone. Def pre-order traversal. We will be getting a root. Okay. This is something we have done already. If root not equal none, we can write is not none as well. We can just return as it is. Print root dot data and print sorry, pre-order traversal root dot left, pre-order traversal root dot right. Also in this, we are always calling left first and then right. Okay, so we have to maintain that order. It is not that if I'm saying that children should be called, that call my child, then it can be right or left. No, that is not the case. Let me write that as well. Always we call left first and then right. Okay, because the order matters in this binary tree. Great. So Cool, everyone. Let us see the output once for this. Pre-order traversal, route 1. Okay, 1 minute. So let us run this. We are not able to see output. Okay, so root if it is none. Okay, if root is none, then I can return. Else I have to just keep on calling and do the recursive call. And now we see the output 1, 2, 4, 5, 3, 6. Okay, let us see the tree. Where is it? Yeah. So 1, 2, 4, 5, 3, 6. Right? Seems that it is fine. Let us copy this as well here. Pre-order, because this is something we are going to use in future as well. Okay, everyone. So I hope each and every one of you are able to understand how exactly is this a pre-order traversal. First, the very first is the parent, then its children, then child, then child. It goes back, then its child, and then child. Okay, cool. So each and every node says that hey, first print me and then go to my children. That is what is happening. Great. Now let us see another kind of a traversal, which is known as post order. Again, something which we have done in our generic tree as well. Here we say that hey, first my children, okay, and then me. So each and every parent says that hey, first the child, both the childs, and then me. So it goes from child to parent. So this exactly how it will go. We will come on one. One will say no, no, don't print me. Go to two. We will go to two. Two will be like hey, don't print me. Go to four. Four will be like don't print me. Go to my children. It doesn't have any child, so I will print it. So the first one is going to be 4. Then we will come back and we will print 2. So we will print 2. Then before 1, we will come back here again. But this time as well, 1 will say that, hey, first please print my children, then print me. So I'm going to see 3 and then finally 1. Okay, so 1 will come in the end this time because it is in a way prioritizing its children. Okay, great. So let us see this as well in visualization, everyone. Let us stop and let us visualize post order. Great. So yeah, let us see. We come to 1, okay, but it is not printed. I think it will get green when it gets printed or it gets traversed. 1 is going to make the call to 2. It is not turned green. In pre-order, it turned green, which means that we have traversed or accessed its data. As of now, we have not done the same. 2 again will make the call to 4, and the call to 4 is made. Right, everyone? So you can see the calls, how they are getting made. 1 calls to 2, 2 to 4. They are not green as of now. Okay, not green, which implies not traversed or basically printed. Okay, great. So let us now move forward. 4, no children are there, so it will turn green. See, this is the first one to turn green. So in my answer, very first is going to be 4. Now let's see which is the next one to turn green, everyone. Next one turns 2 as green. Okay. But you will notice one more thing here, which is 1 is still not green and it called on 3. Because I'm doing post order, I'm saying that hey, first do all my children. And again, left, then right. It's not that you can do either of them. It's left first and then right. Now 3 will call on this. Let us move forward. So 3 calls on 8. 8 turns green third. Now let us see. Then it calls on 6. See, up till now as well, 3 is not printed. Then it calls on 6. So 6, then 3, and then finally 1 is left. Okay, everyone. So I hope this overall visualization is helping you a lot. Please make sure that you understand the whole intuition. That's why I'm putting so much effort in explaining you the visualization. This visualization is very important in making sure that tomorrow you are also able to solve the questions on any other platform, on any OA, or in an interview. Plus, it will be a lot helpful if you will be able to explain to your interviewer with this mindset, with these overall visualization or examples, not just by definition. Many students they just remember the definition, and that is not what I want any one of you to do. Okay, great. So yeah, if the whole is clear, then maybe we can run this again for quickly to see. Let us replay. First one, then it goes to 2 and then 4. 4 gets printed, then 2, then 3, 8, 6, then 3, and then 1. Okay, great. So let us try to code this as well, everyone. Def post order traversal. Okay, root. I can actually copy this whole and easily make a single change. The change is just going to be this. So what I'm saying, and I've copied this code in front of you so that you know that it's good. If you have written some code in logic, just try to see that what changes can you do in that for easier code at least. I am saying that hey, if root is none, then return. Else, first call on my left, then call on my right, and then finally call on me. Okay, great. So let us see the post order traversal, everyone. 245361. Okay. So let us see this here as well. 1 minute. It is calling 245361. Just a second. Okay, 24. We have made a mistake, I think. 1 minute, everyone. So again, should copy code less than. Great. So yeah, if you're copying the code, please make sure that we are handling everything properly. Now let us run this, and it is fine now. Okay, great. So now we can see that first, then second, then fourth. So fourth will get printed first, then 5. Once both the children have been done, then 2. Okay. Then we will go on 3, but 3 will not get printed unless its children are printed. So 6, 3, and 1. Okay. So this is the case, everyone. So we're learning. Anytime we are copying the code, please make sure that everything is checked. Great. So let me copy and save this as well. Post order. Cool. So there is one more traversal which is there in my binary tree. So let us learn about that as well. The last one is known as in order traversal. In order traversal. In order traversal basically says that hey, first print the left one. Okay. First the left, then me. So each and every parent is saying like this that make me a part. Okay, take me in of the order. Then the right side. Okay. So it becomes something like right left child, which is your left subtree. Then your becomes parent, and then it goes to your right child. So this time my parent is saying that hey, make me a part. Okay. So how it the answer is going to be 1, 2, 4, 3. So one will say that hey, first call on my left. 2 will say that hey, first call on my left. So the answer is going to be 4 because no left is there. Then we can print 2. This time before sending to 3, one will say that hey, now make me a part and print me as well. So 1 and then 3. Okay, everyone. So this is the in order traversal, the third traversal in our binary tree. This again is not possible in generic trees because we have many children there. right? Great. So let us see the same in visualization as well. Visualize in order. Okay. So let us run this and pause. See, 1 as of now, we have just seen, it will ask us to go to 2. 2 will ask us to go to 4. Now, since 4 has no child, 4 will say that, okay, print me. Then we will print 2 as well. So let us run till here. Now, in the last, basically the pre-order traversal, my post order, sorry, in the post order traversal, 1 was not getting printed and it was sending it directly to 3 to first get it printed. Post, right? Once all my children are done, post that print me. So always remember this with these words. Post, print me, post all my children's. Pre, print me, pre all my children. And in order, print me within my children's. So this call was sent to 3, but this time 1 will be like, no, print me within. Okay, so let us see that in action, everyone. This time 1 turns green. See, first 1 turns green. Then we can move forward. 3 will turn 3 will again not get printed. What will happen here? 1 is there. 3 will say that, hey, first call on left. So left, no children are there. 8 will get printed. This time again, 3 will not send this call here. 3 will first get printed itself and then send the call. So 8, 3, 6. 3, 6. Fine. Last one is the 6. So you will see one thing. Fourth is the leftmost node. 6 is the rightmost node. Right, everyone? So I hope you are able to see this particular thing. This is very important. We will be doing some question going forward on this particular understanding. So that's why I'm making sure that each and every one of you are able to understand it properly. Okay, so I will just write and summarize it down. First, let me write the code for in order traversal as well. That will be helpful. So for in order traversal, what we have to do, we will be getting the root. If root is none, we cannot do anything. We can just return. Okay. Now, first my overall route is like that, hey, first call on my left. Then you can print me if the in order traversal of left is done. So when I call this particular function at 24, this basically means in recursion terms that you have done the pre-order in order traversal of left. Okay. Then print me. This is the work which we are doing. Root.data. And once I am done, then just do the in order traversal on my right as well. And yeah, this is how we should be fine that in order traversal is going to work. Again, I will repeat. First the left, then me, then the right. Let us run this, everyone. And we see 425136. Let us see it quickly. So we will go all the way till here. We will print 4. Then 2 will print itself. And then 5 will get printed. Once the left subtree is done, we will print 1. And then 3 and 6. 3 and 6. Right, everyone? So I hope, yeah, we are getting the same answer. Let us copy and save this as well. In order traversal. Great. So yeah, I think these are the major traversal. We also learned about the level wise traversal, but that is majorly to make sure that we are able to see the tree more nicely. Okay, but majorly in questions you will be seeing these traversal being asked. Okay, everyone. So let me summarize this once. First, we had pre-order. Pre-order says that, hey, first print me, then my left child, like then do the pre-order traversal on my left child. and then do the same on my right child. So this is how your pre-order happens, everyone. This whole will be done pre-order. This whole will be doing pre-order. Great. Second is post-order. This time my root or the parent says that, hey, first do it on my left child, then do it on my right child. Then just root. Okay. So again, this is the whole function or traversal which we are doing, everyone. And last is in order, in which we say first do the left child, then you can print me, and then the right child. Okay. Yeah. So something like this we have to do. Let me make it little nicely. Yeah. So this is exactly all the different traversals we have studied. Now, in order was not possible in binary generic tree because we have multiple children. Where are we going to insert our root node or the parent node, right? But in binary tree, it is very well defined, which is your in order traversal. Okay, everyone. So I hope this is clear properly. These traversals are very important. We will be using them to do some questions in the next videos. And they are also asked. Plus, in many use cases, it can happen that any of these traversal is helping you to get to your answer or solve your problem. Okay. So please make sure that you revise them properly and try to code it once without seeing the code which I have written. So now you have seen the understanding. Before the next video, try to code it once at your end. Take a tree. Maybe you can work on root 2. Write the code. Write down the answer which you believe should be there and then check the same with your code. Okay, everyone. You will also have my code. So you can just make sure that you are running it if in case you feel that your code is giving the wrong answer. Okay. But please make sure that this understanding gets clear within yourself a lot more nicely so that moving forward, you can use them with a lot of confidence. Okay. Cool then, everyone. Thanks a lot.